Hey everybody, welcome to another DevFest event. Today we have a very special event. It's a follow-up from the previous event. We're going to talk about advanced technique for monitoring production RAG application. This is a direct, it's the following session after we talked about telemetry the last time and LLMetry. This is going to be a very exciting event. I'm not going to take too much time from Nir. Please go ahead and register for the giveaway that will be by the end of the event. So let me send you the link now over the chat. Here you go. Thank you. Nir, the floor is yours.
All right. Hi, everyone. We're going to have an interesting talk today. We're going to talk about advanced techniques for monitoring production RAG applications. And this is a follow-up. This is a continuation of the talk. I hope most of you attended last on Monday. And Nevo, if you can show my screen. Great. So, just for those who couldn't attend last time, I think we're gonna use a lot of the tools and the techniques we've discussed last time with OpenLLMetry for observability. And so, I'm gonna quickly recap. What is OpenLLMetry? So, OpenLLMetry is an SDK which we've built and released as an open source. It uses OpenTelemetry behind the scenes. So the idea is that we enable the collection of the interesting data from a lot of different providers like OpenAI, Anthropic, and also frameworks like LangChain and Llama Index, and also many vector databases like Chroma or Pinecone or Weaviate. And then we send data out as traces and metrics and raw metrics in the standard OpenTelemetry format. And the idea is that you can use that SDK to then connect it to Datadog, Sentry, New Relic, Traceloop, you name it. Any observability platform that supports OpenTelemetry, and there are I think at least 30 or 40 different platforms that already support OpenTelemetry. So that's it. And as I discussed, the different foundation models that are supported, different vector databases that are supported, and the different frameworks. So if you're using any of these, you just use the SDK and you get raw data in the OpenTelemetry format. Some examples from Pinecone of the raw data that you can get. So, for example, you can get the queries you're making to a vector database. So you can see the query, you can see the response, you can see the indexes happening behind the scenes. You can look at the vectors, the actual data that is returned. Metrics like score and latency are all just data that you can get by using OpenTelemetry, and if you're using a vector database like Pinecone. But I think for today we're going to talk about the next level. Okay, so we're using OpenTelemetry, for example, as a tool for collecting a lot of interesting information. And maybe I will stop for a second and we'll show you on the platform what type of information do we actually collect. And so things like cost and latencies and token amount and request amount are all things we automatically collect with the OpenLLMetry SDK. But that's not all. We also look at these what we call traces, which shows you complete executions of multi-step process that may contain calls to like to an LLM like OpenAI and other things. So all of this is what we call raw data that we collect. And the question might be, okay, let's say we collect this data. How do we use the data we collect to monitor our production applications? And before deep diving into what is monitoring in production, let's talk about two closely related terms that people use quite often, which is evaluation and monitoring. So when we say evaluation, we usually talk about the things we do to make sure our application performs well during the development process. And when we talk about monitoring, we usually talk about the things that we do to monitor the application in production. So making sure the application works well at scale for a lot of customers when, after we deploy the application and people are actually using what we've built. And just to give some color to the next couple of slides, I'm going to talk about a real example. Okay, so let's say you have a RAG pipeline. Let's say you have a chatbot, the chatbot that answers questions that the users are asking, or a customer support bot. And so you're writing this customer support bot, let's say, and you're crafting the prompts, you're choosing the model, and then you're probably thinking to yourself, should I use GPT or Claude or Gemini? So to choose between these different models, you want to do some evaluation on each model. You want to run your prompt on a couple of toy examples, a couple of questions that you think that the user may ask, and then see how the model behaves, whether it answers the right the answers that you'd expect it to answer, or something else. And then once you're happy, you've chosen, I don't know, Gemini, and you want to deploy it into production, so you deploy it, and now many users start to use your application. So then you have no idea what type of questions these users will ask, and you have and you still maybe want to check if the answers that the model is returning are correct. So this is monitoring versus evaluation. And I summarize here the differences between why I think these are two quietly distinctive concepts. So when we're doing evaluations, we're usually testing our application on a couple of toy examples, a couple of examples we've built. So we're not super cost sensitive. Doing the evaluation, making sure that the answer is correct, is something it can cost us a lot of money to do the verification, but we're fine because we only have a couple of examples. So for example, we can just look by ourselves or ask someone else, someone who can tag messages, some annotator, to just look at the answers and tell you, okay, this is a good answer, this is a bad answer. And so the cost for doing this sort of evaluation can be super expensive, but we don't care because the number of examples we're running on is super low. Latency is also not important, right? Let's say I'm running the model on a couple of examples, and then it takes me a couple of minutes or even a couple of hours to get this scoring, to know where the model got it wrong and where the model got it right. That's okay, because I can wait, I can do other things. I don't care about if it takes a lot of time. I can just wait for the evaluation process to be done, and then I can see the answers. And the last point, which is I think I might say one of the most important part, is that many times I have what we call a ground truth. So let's say I'm asking a question, I'm writing a question that I'm asking the chatbot. I know what the answer should be, right? If I'm asking a support chatbot, hey, can I get a refund or something? I know if the bot should answer yes or no, or maybe you should just ask for more details. So I know the ground truth, I know the expected answer, and this makes it so much easier for me to check whether the answer that was actually received is close enough to the ground truth, so the right answer that I think should be. Monitoring production is really different. First, it's a high throughput. So, there's millions of users. Hopefully, if your application is successful, you have millions of users. And so, each evaluation needs to be super low cost. Otherwise, you'll go out of money. Let's say if you have, millions of users asking you millions of questions a day, and each, of these millions results cost you 1 cent to test, then the cost will be really, really high. But during development, if you only had 10 or 50 or 100 examples, 1 cent is nothing. It's $1. But for millions of examples, it's super, super expensive. So the cost for doing production monitoring has to be almost zero. Latency is really important many times, because if I can tell in real time that the LLM is going to return a wrong answer to the user, maybe I want to know about it, before I'm actually returning that response to the user, and tell, hey, stop, don't return that answer, do something else. And so latency can be really important, because I may want to use it, what I wrote here as guardrails. So I may want to block certain responses forever reaching out to the user. So if doing the evaluation, testing that the answer is correct takes me a couple of minutes, it doesn't make sense to do it in production. And lastly, and again, super important, I don't have a ground truth, because I have no idea what users will ask. What types of questions will they ask the bot? So I have no idea what are the potential answers, right? So when I'm writing the questions myself, I know what the answer should be. But when I have millions of users asking millions of different of questions, there's no idea for me to tell, okay, this is the expected answer, this is the right answer, and this is the wrong answer. I have no idea. I actually need to go and test the answer that the bot returned without knowing what's the right answer. And so I'm going to talk a bit about ideas on how to do it in production. So I think, looking at these two comparisons, I think it can be clear that I would say most of the metrics that you can use for monitoring in production can also be used during evaluation. But not vice versa. The monitors you're using for evaluation, you can't really use in production. So for this talk, we're going to focus on metrics and things you can do for doing monitoring in production. And remember that they must comply with all of these requirements. They must support high throughput. They must be relatively cheap to run. The latency should be pretty low, and they should never assume that we know the right answer that we can use as a comparison beforehand. By the way, if anyone has any questions, feel free to write them. I see the chat. So if you have any questions, if you have any thoughts, something is not clear, write the questions down, and I'm happy to give answers. So the most simple metrics that you can use, and these are really $0 for running those metrics, are latency, cost, and errors. And if you're not checking them, if you're not measuring them and monitoring them constantly in your production application, do it. If you're not doing it today, you have to do it. Like, go finish this, hearing me, and then just go and add these metrics to your application. We have them in the open source, in OpenTelemetry. And the reason they are so important is because they can tell you a lot about what's going on behind the scenes. So, for example, latency is a really interesting metric because, first of all, it affects the users. Because if the model is taking a lot of time to produce an answer, then we have a problem. But also, it's a good proxy metric into how well if something radically has changed. Let's say you deployed a new version and suddenly latency has gone up the roof, then something is wrong. You don't know what is wrong, what's changed, but you know that something radical has changed. Maybe, for example, the prompts became a lot longer. Maybe you switched the model. Something changed, and it's important to and it's a good signal that something is not right. So monitoring latency, and kind of similar, I would say, monitoring cost is two things that can give you a sense if something is not right. Cost, of course, is really important because if you're not monitoring cost, you have no idea how much does it cost you to actually run your application. So make sure you're checking whether running your LLMs in production is not too expensive. And error rate is also really important because you never know what types of errors you'll get from the LLMs and when you run them in production. There's tons of different errors that you can get from just temporary failures in models, if there's like outages in the model provider or something like that. But errors can also be things like you've hit the rate limit, you've sent too many requests to that LLM in general or in a specific period of time. There are a lot of ways and reasons why LLMs can fail, and you have to monitor and make sure that that you check for errors and see, again, if there are no spikes or changes or issues with the error in your application. The second thing that you'd wanna measure, and again, these are super low cost. So if you're not looking into these metrics, do it today. The second types of metrics is what we call providers metrics. So providers metrics are some metrics that the providers you're using, like OpenAI, Anthropic, Pinecone, Chroma, and many others, they just give it to you out of the box. Just because you're using that provider, you get those metrics. Sometimes you need to make a change something in your request to enable these metrics and get them back. But most of the time you're just getting them anyway, but you may not be looking at them. And the two examples I've given here are Pinecone scores for Pinecone, and other vector databases support them as well, and OpenAI log probes. And unfortunately for log probes, OpenAI are still the only LLM that I know of that send this data out, although you actually need to configure it and enable it to get this data back. So what are Pinecone scores? Pinecone scores are a crucial part of the way a vector database operates. So let me remind you, what is a RAG pipeline and why do we need to use a vector database to begin with? So a RAG pipeline is a technique where I want to get an answer to a question and the model doesn't know the answer. Let's say it depends on some internal knowledge base or like documentation that I have internally. And so what is commonly being done is I'm taking this internal knowledge base, I'm indexing it into a vector database, and then whenever I get a question that I need to answer using that knowledge base, what I'm doing is that I take the question, I go to the vector database, I find documents or pieces of that knowledge base which are closely related to the question that I've asked, and then I send those pieces of text together with the question to the LLM provider like OpenAI. And so when I'm taking the question and searching for relevant documents in my knowledge base in the vector database, the way I'm doing it is that I'm using some of the vector database's proprietary models of how to find closely related documents, and each vector database may have different definitions of what are closely related documents. And usually what you get back is the documents themselves, which is what you send later to OpenAI as the context, but you also get scores. And these scores give you a sense of how close these documents are to the question. So let's say I've built a RAG pipeline for my documentation for we are TraceTube. So for TraceTube documentation, we have a chatbot, and let's say we have we index all of our documentation, and then we allow our users to ask questions about our documentation. And let's say some user asked how to use TraceLoop. So I will find the RAG pipeline will find the documents related to how to use TraceLoop, and we'll get 3 documents. Probably all the scores will be pretty high. But let's say the user asked who is the current president of the United States. Probably we don't have an answer for that in the corpus in our documentation. So the scores I will get back from Pinecone are pretty low. This is why monitoring those scores is really important. It can give us a good sense of whether the model is going to hallucinate, because if the model is getting a context which is unrelated to the question that the user has asked, the model will probably don't know how to answer the question. So just looking at the scores can be super valuable and can give you a lot of insights into how well your application is performing. And of course, we have these in OpenTelemetry. OpenAI log probes is kind of similar if you think about it, but more around LLM functionality. And the way it works is that if you enable it, for OpenAI specifically, you need to ask during the request you want to get back the log probes. So the log probes will give you back for every part of the answer. So for every token you've gotten back in the answer, it will tell you what's the confidence that the model has for that token, for that answer. So if you think about it, if you average if you average all the log probes of the response that you've gotten, it gives you a good sense of how confident the model is on your answer. So again, this is a great way and super low cost to run to get details into how confident the model is in the answers they're providing. And if you ask a question and you get an answer and the log probes are much lower than usual, then you know, hey, I have an issue here. I've gotten a response that may be a hallucination because the model wasn't sure, as it usually is, about that answer. So two super simple metrics you can enable today with OpenLLM and can give you a lot of understanding of how well your model is performing in your overall application. And the last type, and I think this is the most complex type of metrics, are NLP metrics. So NLP metrics cost. They're not for free. You don't get them from the LLM providers, and it will cost you to actually run them in production. How much? Depending on the type of metric that you choose. So I'm going to talk about two types of metrics, and each bullet here we can do like 1 hour conversation just on that. So we're not going to talk about them in depth, but we're going to briefly discuss them. The first category is the classic NLP metrics. The most well-known ones, and these are things you can search and look for after this talk online, are BLEU, GRUN, and the BERT score. These are classic NLP metrics that have been around for a while, sometimes even more than 10 years. And while it may seem weird that we want to use like a really old metric, kind of like something that was developed 10 years ago, we want to use something like that to evaluate the quality of the outputs, it may sound weird to you. But it actually it's a pretty great idea if you try to remember what we talked to at the beginning, which is we want to find the metric that is economical to run, that is low cost and can run at scale. So these metrics usually depend on small models or just techniques, even just algorithmic techniques that you can run on your application, on the outputs you're getting, and they're super cheap to run and give you pretty accurate results. The second category is LLM as a judge metrics. These became really popular in the last year or so. I think if you look at metrics like open source projects like Ragas, then they use LLM as a judge behind the scenes. And the idea is that, okay, we got an answer from an LLM. We sent a question, we got an answer. Let's look at let's ask another LLM if this answer is correct. So this is why it's called, LLM as a judge. And some of the most common terms you may hear around this is faithfulness, relevancy, and many others, which are like it kind of became common terms for checking different types of hallucinations or errors that can happen in production. The good thing about the LLM as a judge metrics is that they correlate well with human judgment. So experiments that companies have done, and we have done that as well, shows that for some of the use cases, LLM as a judge metrics work pretty well. Because if you think about it, like the best way for me to evaluate the quality is just to ask some human being to look at the answer and tell me if the answer is correct. This is super expensive and super slow. So if I can use an LLM and the answers that I'm getting are pretty close to what I would have gotten from a human, then I'm doing something right. I would just note that this is not always true. So even this is known to be correlating well with human judgment, you still need to make sure it for your specific use case. But as we said, if you remember this slide from the beginning, for monitoring, for production, we need something which costs almost zero to run. And LLM as a judge, while it may correlate well with human judgment, is not something we can actually run at low cost in production. We are basically paying twice as much as we were paying before just to evaluate the first LLM call. So what do we do? How do we choose metrics how do we choose the right metric to use? As I said, LM based metrics can be more accurate, but they're more expensive to run. And classic metrics are more, are more economical to run, but can be less accurate. And if you think about it, there's a good reason why LLM-based metrics or LLM as a judge metrics are working pretty well. This is why we all love LLMs and we all want to use LLMs everywhere we could. First, they've been trained on huge amounts of data. They correlate well with human judgment, as you said, and the third point is actually, I think, the most important one. They're very intuitive. If you think about it, just asking an LLM if an answer is correct is like super. It's the easiest thing you can think about. It's like just asking another human being, "Hey, I've gotten this answer for this question. Is it the correct answer?" So if you can ask it an LLM and get, a good evaluation metric out of it, then great. It's like it's super easy to understand. I would note that not of the LLMs judge metrics are that simplistic, but you'd get the point. You still just ask questions the LLM, get answers, and then use the answers to calculate some metric. And if we want to advance it a bit more, some of the solutions we can think of is just trying to combine classic metric approaches with LLM as a judge tools. And the idea to approach it is that, well, first we need to do some work. We need to understand how to evolve and retrain or fine tune some classic metric so that it can closely approximate those good LLM as judge metrics. But in order to prove that we've actually done something right, we basically need to prove that those improved classic metrics actually correlate well with LLM as a judge metrics. And if you want to make our lives a bit more easier, then we don't even need them to correlate exactly, but we just need them to agree on what we call directionality. So they don't need to correlate. So if you think about it, you get a number for the classic metric, and you get a number for the LLM as a judge metric. They don't need to correlate, but they need to agree on the directionality. So if the classic metric said negative, some low score, and the LLM as a judge said high score, so good, this is not something that we want to do. We want the metrics to agree on the sign and agree on like the negativity. So both should either say negative or both should say positive, but not the other way around. And the way and one of the things we've done specifically on Traceloop is we've done exactly that. We've built one of the metrics we provide on the platform. It's called soft faithfulness. And soft faithfulness uses some sophisticated vector embeddings techniques to quantify the relation between a context and an answer. So remember, we have a RAG pipeline. We have some question. We go to the vector database and we get the context. And then we take the context together with the question and then send it to an LLM and get an answer. And so faithfulness is asking, does the answer appear in the original context? Yes or no? And the way you can do it is either use the RAGAS faithfulness matrix, which uses another LLM, or the soft faithfulness, which is based on vector embeddings to get a good approximation to that same question. And this is, you can see a nice diagram here of a comparison of Traceloop soft faithfulness to RAGAS faithfulness. As you can see, they agree on the sign. So most of the times, when RAGAS faithfulness gives a score of 0, which means that the answer is not faithful, Traceloop soft faithfulness also gives less than 0 scores, which also means negative. So by using Traceloop soft faithfulness, we get a good approximation of the RAGAS faithfulness metric. And I think this is not the end of it. We're gonna show you a quick demo and a quick example right now. And I think if you want to build your own metrics, there's basically an easy path to go. I think just following this recipe will give you a good sense of how to build a low cost metric that correlates well with high cost metric, with expensive metric, which use LLM as a judge. You start with LLM as a judge metric. You take one of the classic NLP metrics, and you try to retrain them or fine tune them to correlate well or to agree on the negativity with LLM as a judge metrics. It's kind of it doesn't, it's not that complex, but it's like it's a good way of like thinking about this problem. That's it. This is a link to our open source OpenTelemetry. This is Trace of the platform if you want to try one of our metrics. And we're happy to consult. Tracelab.com/consult. You can talk to us if you have any questions or you want our help to build some custom metrics. Demo time. Questions or anything, feel free to ping me and here on the chat, and I'm happy to answer. So for the demo time, we're going to show you a quick, a simple RAG pipeline, and we're going to see, the different evaluations we can run on those RAG pipelines. And this is how it looks like. I've built a simple RAG chain that uses Pinecone as a vector database behind the scene. And what's happening is that we took all of our documentation, so tracelab.com/docs, we indexed everything with an embedding model. And so we embedded it with the embedding model, and then we indexed it into Pinecone. And then when the user asks a question in a chatbot we built, we're embedding that question, sending it to Pinecone, getting some relevant context, and then using GPT-4o to get an answer to that question based on the context we've gotten back from Pinecone. And the context is coming from some documents of that we've gotten from Tracelab docs. And everything is observed with OpenTelemetry. Let's see it. So first, let's look at the code. The code is also open source. It's tracelab.com/demo. It's super easy to read. And if you look at it, most of the code here is just the UI for, we're using Streamlit. So it's just for configuring the UI. But behind the scenes, we have the GPT-4 model, and we're using the text embedding 3 small of OpenAI, and we're using Llama Index to help us build, the RAG pipeline. And then, we're loading all of our documentation. We're storing it in a vector database. And then whenever the user asks a question, we run the RAG pipeline. Super easy. As you can see here, we just... we're building a chat engine with a Llama Index, and then we run it. So let's see it in action. If you go to our documentation, click on the demo, then you can see the chatbot, which is based on the code that I've just shown you. And this is a chatbot. Let's ask it some simple question like, how do I start using Traceloop? And you'll see it will think, and it will provide us an answer in a couple of minutes. Great, we got an answer, and I think it's pretty accurate. I hope you can all, see what I've done here. So I ask it a question, and I've got an answer. But let's see how it looks like behind the scenes on the platform. And we're going to switch to the demo account for that. And if you go to if you want to see it for yourself, notice that in our documentation there's just log in with these credentials, and you can also view the demo account by yourself. And so I'm going to do that. I'm going to log in. And let's see it. Let's start with the trace as we did last time, and let's go to production. And yeah, this is the one. And as you can see, it was quite a complex trace. It's kind of surprising, And as you can see, we've done a lot of calls behind the scenes. So the overall, it took us some time. It took us 14 seconds to get an answer. And as you can see, I asked, how do I start using Traceloop? And then I got, this response to start using Traceloop, blah, blah, blah. And this is what we've seen, in the demo. And there was a lot of things happening behind the scenes. There's like a call to OpenAI. There's another retrieval flow where we said, okay, how to start using Traceloop, and then we got a couple of documents, and then we called an embedding to actually embed so we can get the data from the vector database. And then we did another call to OpenAI where we ask it, the common, you are an expert QA system that is trusted around the world, blah, blah, blah. And here is the context. Here's some relevant documents from our documentation. And it's pretty long, but it's interesting to see that. And this is the question. Given the contact information and no prior knowledge, answer the query. Query how to start using Traceloop. And we got an answer. And then we need another call to OpenAI to format that answer. And then this is the final format that we actually gotten back in the UI. Someone asked about the presentation. So yes, the presentation will be available. And the repo as well. Everything I showed you is open source. You can view if you have any comments, suggestions, issues, pull requests. Feel free to send them out. And yeah. And as I said, this is nice to understand what's happening, but we can also define all sorts of metrics on top of that. So let me show you some of the metrics we have on Traceloop, which on Traceloop we call evaluators. So there's like many different things you can evaluate. For example, if you use a platform like Traceloop, because there's like many ways for you to check the quality of the answer you're getting. So I'm not going to go over all types of metrics we have here, but I'm actually going to focus on a metric that was running all this time, which is QA relevancy. QA relevancy is a really important metric for RAG pipelines. It's basically looking at the question that the user has asked, looking at the answer that the model has returned, and checking if the answer is actually answering the question. So let's see how it looks like. So as you can see, I've used the chatbot for around 18 times for the last 14 days. Most of the times it got it right, but sometimes one time it failed. And I can easily, deep dive, debug it, and I don't know what's happened here. There's like a weird UI bug here for some reason. Maybe it's because it's big. It's too big. Let's try it again. I don't know what's happening here. Anyway, when this actually works, you can actually deep dive and debug those issues. And we have a weird issue here in the UI. Yeah, so this is basically it. If you have any questions or comments, or you want to hear more about metrics, ping me here on our Slack, traceloop.com/Slack. And yeah, I hope you enjoyed this talk, this conversation.
Awesome. Thank you so much, Nir. That was super insightful. I hope people learn a little bit. Please, if you like that and there is still time, go ahead and start Traceloop. I'm putting the repository over the chat, so please give them a star. Also, they have, if you go to their main website, you can see that they have some awesome swag and things that you can do in order to win it. So go ahead and contribute, of course. Thank you so much, Nir. And we are now going to move into the giveaway. So let me share the screen with you all. All right. Just to recap, I'm basically spinning the wheel. I'm going to get 2 people. I'm going to ask in the chat if you are here. If not, I'm going to spin again. If you are here and you submitted your name more than once over the Excel file, then I'm going to disqualify you automatically and move to the next person. Basically, by the end of the competition, because you used your GitHub handle and you are logged into the system with your GitHub handle, I'm comparing them both, and you will have on the system, on DevFest, a way to claim your swag, to put all your details, where to send it to. This will be by the end of the event. So let me spin it. By the way, if you are a new account, and it kind of looks like you're trying to cheat, I will also move to the next one. So Dark Developer 15, okay. Sartak Tiagi, I think you actually won also last time. Let me see here. Dark Developer. Yeah, are you here with us over the chat? Dark Developer 15? Oh, actually, I see that you comment in the last 2 messages, even though you don't say it's me. I see you here. All right, cool. So let me mark you. I think you already won one, so I'm not really sure. So you're going to get double swag. All right, next person. Okay. Divaya 4872. I see that you are here. You have a full repository. Are you here with us? Let me check that you haven't cheated. All right. Are you here with us over the chat? Divaya? I'm gonna wait like 10, 20 more seconds. Divaya 4879, sorry. All right, so let me spin it again. Next person. All right, Muhizol on GitHub. Let me see. Muhit Dashmua, something like this. Sorry about that. It's kind of hard to say this. Let me see that you submitted only once. Feel free to write over the chat. Yep, only once. So are you with us? NYLD, what do you mean it's me? It's kind of hard to verify that it's you. All right, so I'm marking you as a winner. Thank you, everybody. And I will see you all next week.